Okay, so now we're going to turn an entire radical into a mixed radical, and we're going to use prime factorization. So that's something in our wheelhouse because this can be the second unit that we've used this for. Okay, so what I usually do is I go like this, and I know you guys like to use the factor ladders, so that's what I'm going to do. Smallest prime number that goes into 72 is 2, goes in there 36 times. 36, smallest prime number that goes in there is 2, and you get 18. 18 is also divisible by 2, you get 9. And now 9 won't be divisible by 2, but it's divisible by 3. You get 3. 3 is divisible by 3, and you get 1. So here are your prime factors listed there. Now we're looking for a square root, and a square root implies that we are getting numbers that show up in groups of 2. Here's a group of 2. Here's another group of 2. So think like this. What's 2 times 2? 4. What's the square root of that? 2. 3 times 3 is 9. What's the square root of that? 3. So this is how I shortcut it. I go 2 times 3, and 2 times 3 is 6. And what's left over? The square root of 2. So that's our answer. Entire radical to mixed radical. Okay, 80 divisible by 2, which is 40. 40 divisible by 2, which is 20. 20 divisible by 2, which is 10. 10 divisible by 2, which is 5. And 5 is divisible by 5 to get 1. Okay, square root, remember the index is invisible there, but it's a 2, so we're looking for numbers to show up in groups of 2. I got a group of 2 2s and another group of 2 2s. 2 times 2 is 4. What's left over? This 5. So from going from an entire radical to a mixed radical, you get 4 root 5. Okay, you're looking for factors that show up twice. All right, now we're looking for numbers to show up in groups of 3 because our index is indicated here that it's a cube. 3, okay, the cube root of 24. Same principle. We're going to divide. Remember, when we're doing the factor ladders, we always have to end up with 1 here. So is there a group of 3 numbers, 3 factors that show up? Yes. Okay, right here. Okay, so we go 2 is the factor that shows up 3 times. What's left over? A 3. And we have to remember to write the correct index in there. If we didn't write an index, remember it's 2, and then that's not going to be a correct answer. Okay, keep going here. Cube root of 144, we're going to divide that by 2. 144 divided by 2 is 72. 72 divided by 2 is 36. 36 divided by 2 is 18. 18 divided by 2 is 9. 9 divided by 3 is 3. And 3 divided by 3 is 1. Okay, now we've got an index of 3 there. So are there any numbers that show up in groups of 3? Certainly, right here. So we're going to write down 2 cube root, and now we have all these numbers left over. So what we do is we just multiply them together. 2 times 3 is 6. 6 times 3 is 18. Okay, so that would be our answer. Now we're going to go over here and we're going to move on to a 4th root. Okay, and see, this is why I like using this prime factorization. I don't know all my 4ths. Okay, that's just not something that's in my wheelhouse, but I can quickly knock off a factor tree or a factor ladder. Okay, so cube root of, or the 4th root of 162. 162 divided by 2 is 81. 81 is no longer divisible by 2, but it is divisible by 3. Okay, we get 27. 27 divided by 3 is 9. 9 divided by 3 is 3. And 3 divided by 3 is 1. Okay, and now we're looking for numbers to show up in groups of 4, and here we go. We got 4 3s right away. This one turned out to be easier than some of the other ones. So we have 3 as our coefficient, our number that we're pulling out for the mixed radical. Okay, we've got a 4th root. We can't ever forget that. Okay, what's left over? Simply that 2. We didn't have to multiply it together with anything. Okay, and I realize this is new. Okay, this is not something that's in your wheelhouse. Okay, so if I asked you to try to simplify each radical, start it as an entire, simplify just means turn it into a mixed radical. Okay, that's just a shortcut word for that. So same thing we're going to do here. We're going to divide 60 by 2. We're going to get 30. 30 divided by 2 is 15. 15 divided by 3 is 5. 5 divided by 5 is 1. Okay, we know that there's an invisible 2 here, so we're looking for, because the index is 2, numbers that show up in groups of 2. Here we go, right here. 2, and then we write down the radical sign. What's left over? 3 times 5, which is 15. Okay, and I'm going to show you right now how you know you're correct. If we took the 2 out, it means that it originally was under here 2 times. So this is how I shortcut it to get back to my entire radical to check my work. 2 squared, because that's what that index is, remember, is 4, and 4 times 15 is 60. So I know I did that one correctly. Okay, we're going to put a star beside this one, okay, because this one's a little bit of a trick. If I divide 26 by 2, I get 13, and what do we know about 13? 13 is a prime number. So we're looking for numbers to show up in groups of 2. No numbers show up in groups of 2. So we can't even turn this mixed radical, or this entire radical, into a mixed radical. We just leave it like it is. Square root of 26. That one won't work. All right, cube root of 40. Looking for numbers to show up in groups of 3. Did any numbers show up in groups of 3? Sure did, right there. We got 3 2s. So we're going to write down 2 as our coefficient. Cube root, we can't forget our index. What's left over? That 5, and that's our answer. How can we check our work? 2 cubed is 8. 8 times 5 is 40, so we know we did it right. Okay, we're looking for numbers to show up in groups of 4. Okay, so here we go. 16 divided by 2, 8 divided by 2 is 4, 4 divided by 2 is 2, and 2 divided by 2 is 1. Okay, so looking for numbers to show up in groups of 4. There's our 4 2s. We're going to write that down. Remember to write in our index. What's left over? 2. How do we know we're right? Well, 2 to the exponent 4 is 16, and 16 times 2 is 32. Okay, now what we're going to do is we're going to write mixed radicals as entire. So the shortcut looks like this. The 4 is out here as a coefficient. Okay, if we wanted to get it back under the radical sign, we think 4 squared is 16, because what this really means is we would have had 4 times 4, 16 times 3, which is 48. Okay, so we're just going backwards from this. Here, 3 cubed is 27, right? And 27 times 2 is 54. One thing we don't want to forget is that index. 2 fifth root 2. That's how we'd say that. 2 fifth root 2. Okay, so what's 2 raised to the exponent 5? 32. 32 times 2 is 64. Mixed radical, entire radical. All right, you guys are going to try these ones. This lesson we're going to do again tomorrow, okay? I get that it's a little bit weird.